EDA. Okay, outlier detection and everything needs to be discussed. So before that, let me tell you, when we are talking about evaluation matrices in classification, what are the evaluation matrices are there for classification based algorithm? Anyone? I have discussed in the last class. What are the classification evaluation matrices? What you guys are doing, I don't
Sir,
know.
these are, sir, accuracy, precision, recall.
Yes, what is accuracy?
Sir, it is calculated basis on true positive plus true negative divided by total number of observation.
I have to mention that this is for classification. Then these are for regression. What is accuracy? It is true positive plus true negative upon total number of observations. You guys are getting it or not? First tell me. If any sorts of doubt, do you want me to? You guys are there, everyone. I don't know. You guys
Yes,
are
sir, we are getting
Yes,
everything.
sir.
getting it or not?
Yes.
Yes,
Please
Yes, sir.
raise your
Yes,
please
sir.
raise your hand, all of you. Those are not getting. Those are not getting. What I
Sir,
am discussing.
we are
Yes, sir.
getting little bit because of we are not doing. That is why we are not performing these calculations on the real time.
Aniket, you are not getting it?
sir. Repeat hard, sir.
Manya, you are not getting it? Just any sorts of confusion you can. Manya, are you there? Rafat Ali,
Yes, sir.
you're getting it or not?
Sir, I'm getting it, but it is we are not implementing, so that is why it's a bit.
You are not implementing.
Yes.
Okay.
On the
Then
real time, so that is
have
why
I
it's hard
discussed
to
about the
understand.
Python for data analytics? Have I discussed? I've told you right to learn Python. I told you
Yes, sir.
right.
Yes. Basic I have learned, sir.
Open Google Colab for all of you. If you're not getting it, then why I'll discuss? Totally waste of time. Just hold on. Have I shared this evaluation matrices? No, I think.
No, sir.
I'll share it. I'll share it. Okay. I'll show you something. One is working on your project, right?
Yes, sir. We are working.
Yes, sir.
Yes, sir.
Because end of this week or next week, first onwards, I'll take the first review.
Sure, sir.
First review means what's the progress to check.
Okay, sir.
So this is logistic regression. This is a classification model. So here, from scale matrix, import the classification report and all the things, precision, recall, F1 score, support, accuracy, all things you can show in classification. Okay. without diabetes, with diabetes, the diabetes data set I've given, then the classification report according to Y test, Y grade, the target names you can give the variable as target. Getting it? You all know how machine learning algorithm actually works. Any idea?
No, sir.
Okay. All of you, this is a gentle reminder for all of you that to learn Python within 15 days so that from the next month onwards we can discuss about this. Okay, because for your domain, what are the stuff that I think I've already told you regarding that what are the things that important for your domain. Okay, have I told you?
Yes, sir.
Yes, sir. You have told us that you have
Then
to
what are the
consider.
things? Python fundamentals, data
Yes.
wrangling with SQL, statistics and probability. Probability and statistics also I'll discuss. Bayes theorem I'll start with mathematics and then Bayes theorem. Then machine learning, performance matrices that we are discussing, evaluation matrices, time series forecasting, data modeling is important, and then Microsoft Excel, then visualization using Power BI and data analysis and visualization using Python, like Matplotlib, C1, Plotly, all this. Okay, these are the important stuffs that you can you all must have must have the ideas. Getting it,
Yes,
all
sir.
of you. So,
Yes, sir.
so the first one that Python is the task
Yes,
for
sir.
all of you. If I talk about Python, I can discuss. Okay, I can clear your doubts as well, but it will take much time. Okay, if I talk about Python, this is not the intensive program for Python development. This is for data analytics. So you learn Python, all of you. This is the task, and this is a humble request to everyone, so that we can proceed further. Again, every batch I'm asking this. If you have not any idea about Python, please go for it and understand what we're discussing, what we'll discuss, what are the prerequisites for us. Okay, I'm giving you the type. You just understand how Python scripting, how to code in Python, how it works, what are the variables, functions, what are the data types, constructor, loop, if else statement, then for loop, while loop, then your various functions, how that it works, overall knowledge. Means within 5 to 7 days you can complete it. If you'll give 1 hour only to Python, you can get it, how absolutely works. If you can understand that much, and normal Python code like how to print the addition, subtraction, Fibonacci sequence, how to recursive function in Python, how to you are visualizing various Python plots, box plot, uh, how to import various libraries, box plot, line plot, how to visualize it, analyze it using Python, how the model actually works, what are the sorts of code we can use. This overall fundamentals you just learn. Then after that, all things come to okay. I'll, there's some noise in the background. The voice is not clear. My
Yes, sir.
voice is
Today
not
your
clear.
voice is not clear. Yes, sir. Today is not clear.
Okay.
Yes,
My
sir.
voice.
It's not clear.
Okay. My voice is clear now.
Yes, sir. Quite better.
Yes, sir.
Sir, your
Yes, sir.
voice is clear, but there is some background noise coming. That's why it's not clear properly.
Okay. Okay. Yes, Aniket. We'll discuss about it. Okay. I think you get your courseware, right? Aniket, get the courseware, right, buddy?
Yes.
So this is the course plan for all of you, and I'll tell you about that. And it's your task to go for the modeling using, but it's not that advanced. Okay, that's why the Weka can learn Weka, but it's not that advanced thing that you can understand. Okay. See, see, we are discussing with life cycle that little mouse person. Now, so analytics in different sector, dealing and handling different types of data, structured, unstructured, roadmap. Also, I've discussed. Okay, I'll tell you about the roadmap today. Also. Okay, and this is done. EDA outlier detection imputation project is done. Normalization standardization will take 2 more classes. Weka tool and MATLAB. This is important. I'll discuss. I mentioned this. Analysis visualization using Python. I've not discussed augmentation. Okay, if regular class will be there, then we'll complete this. And this 4th week task, we can move to the next month because we have added this for, these are the stuffs, okay, we are going to learn. Getting it? In these 3 months. Means in 1 week, you will be getting 3 class. Okay, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
So, this is a computer evaluation of process. Participation. I've added many things in the month 1, okay, but in the month 2, I've added very less. So this is the way how actually classification model works. Okay. Then we're discussing. Let me come through the topic. Okay. If we'll talk about it, then whole time will go. Can you see my screen? Because
Yes, sir.
EDA needs to be
Yes, sir.
discussed very soon. So it is very important to discuss EDA as soon as possible. If I'll complete EDA today, the next class itself I will discuss about outlier detection, uh, imputation, normalization, standardization, one-hot encoding, label encoding. If not possible, then other classes. Okay, because you have the time up to 25 or 26, right, to submit the project, right?
Yes, sir.
Then
Yes, sir.
we have 10 more days to cover. So when you're talking also, we have discussed about this. Then what I mean by ROC Corbin classification model. The ROC is. So ROC called is a graphical representation of classification models performance at different threshold. It helps to evaluate the trade-off between sensitivity and specificity. Sensitivity means the recall and specificity. What is in that? The x-axis represents the FPR, that is false positive rate, that can be determined by a false positive or false positive plus true negative. And the y-axis represents the true positive rate or TPR, this sensitivity, that can be formulated as TP means true positive upon true positive plus false negative. Means each point on the ROC core represents a different distance threshold. Okay, first understand what is ROC core. Open. So here, a model with perfect classification has an ROC curve that passes through the top left corner between 0 to 1. Okay. And the model that randomly guesses has an ROC curve close to the diagonal, that is y is equal to x line. Y is equal to x line. Means in that one AUC value, AUC, AUC value measures how well the model separates the classes. If AUC value is equal to 1, that is the perfect model. If AUC is equal to 0.5, that random guesses or bad model where it's okay. How to implement the ROC form, I think here was the required libraries. The libraries first is done. Then from a scalar make classification, train display, support for regression, large regression we work on. Then we are generating the synthetic data. That is xy is equal to make a classification that the samples to be given features in classes, then the non-next. You cannot get it, I think so. Because you are there for ROC curve, if here and DPR and the threshold value that counts your variable like y test and y prep. Then ROC UC, we are determining that AUC, ROC UC is equal to AUC or FPR, comma TPR. And how to plot the ROC curve? This is the required things. The FPR, TPR, the color, label, the plot, the variables, the next level false positive red, y level true positive red. This is the ROC curve and lower right. Okay, means overall, when we're importing these libraries, you need to understand what are these libraries. Okay, so that's why I've told you, just gain some basic knowledge about Python. Then we'll discuss about all these things. It's how to import. Just learn all these things, how to import these libraries. What is the work of these libraries? Why this being used? All these things, if you can understand, then we can proceed further. Means you can get it what I'm actually discussing. Okay. So this part. So all of you, the next class task to learn EDA. I think EDA you all know, exploratory data analysis.
Yes, sir. And this
So
is the
all,
advanced part of machine learning.
yes. So EDA, all of you learn EDA, not in machine learning. EDA is important in data analytics, very important.
No,
EDA
I'm
means
talking about this ROC curve.
yes, ROC call. EDA is very important in analytics because you have to understand the data properly by using various plots and graphs. Okay. So
First of
this
all,
is
we
the
have to install this
this is
package.
yes. So listen, the next am I audible?
Yes, sir, you are audible
Yes, sir.
properly.
The next class, all of you please listen to me very carefully. Let me tell you what's the next class task. The next class task for all of you to learn EDA because today I'll discuss about EDA. After this, I'll start with EDA. The work is to learn EDA. What are the steps involved in EDA? What is the outlier detection, imputation, normalization? Just up to imputation, you just understand and okay. What is EDA? What are the various steps like uh, data collection? Then your what is that? Imputation, outlier detection, up to this. Okay, just learn all these things. Okay, by your own. Whatever you can understand, that just come along with that. Okay, just I'll ask you. Okay, what is your understanding? I'll check. After that, I will discuss. I'll continue. Okay, so that you can understand it better. and you can cooperate with me. Okay, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So here the ROC core. Okay, I plotted the ROC core. Then how to understand? What are the interpretation of ROC core? If in the ROC core, what AUC value is there? 0.9. If AUC value is 1, that is excellent model. 0.8 to 1, that is a good model. Here it's a good model. If AUC value is 0.7 to 0.8, fair model. 0.5 to 0.7 is one model. And the AUC value, if it is 0.5 or less than that,
Kanu, please mute yourself.
was that? Was that?
Someone has unmuted. Kanu. Sorry, Kabunuru.
What's your name, dear? Rafat Ali, right?
No, sir. Someone has unmuted yourself. So it was
Means
Kabunuru.
your name is Rafat, right? That's your
Yes,
activity.
yes, sir. Yes, sir.
So, if the ROC value, that is less than 0.5 or equal to 0.5, is no better than random. The OATS model. Means the ROC core helps to evaluate the model performance at different thresholds, and the AUC measures the overall ability of the model to discriminate between the classes. Okay. If higher AUC will be there, then the better classification performance will be there. And like that. Okay. According to the AUC value, it's written. Getting it, all of you?
Yes, sir.
Then,
Yes,
then
sir.
the mean thing. Then it comes to the main thing. Okay. Then the evaluation matrices, the performance matrices for regression. This is important. Okay. What are the evaluation matrices? When building the regression model, we need to measure how well the model predicts the target value. Your various evaluation matrices helps to access the model performance. Okay. The first one is mean absolute error in regression. What does mean absolute error? Mean absolute error means it is the average absolute difference between the actual and the predicted value. Okay. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Just hold on, please. Yes. Let me-
And also, sir, can we get that PPT? Is mentioned clearly about the data set overview.
What overview? What overview, dear?
So there is clearly mentioned about topics wise description.
Is this one we are talking about?
No, 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 not this one.
This
It-
one.
No, sorry, we have this one. I'm about talking about that chapter wise PPT that in the last class you have shown us. Where is mentioned all the things in the description.
That's a simple one. Okay, I'll share it. This one we are talking about, right?
Yes, sir. Yes, sir. Introduction to data sets. Yeah.
This one.
Yes, sir.
I'll share it today. Okay, I've not
Okay,
shared
sir.
anything. Have I
Yes.
shared anything in your group?
No, sir.
We have this PPT like overview of the data.
Overview means what?
Like what are the things that we have to perform, task and project details that you have shared us.
Means the project.
Yeah, project.
I'll share it today. Okay. So when you're talking about mean square error, mean absolute error. Mean absolute error means this is the average absolute difference between the actual and the predicted value. Okay. It can be formulated as mean absolute error. I'll let you know about this. So mean square is 1 upon n, summation of I is equal to 1 to n. Then the magnitude of y minus y dash. Means the magnitude of actual minus predicted value magnitude. The y is the actual value, y dash is the predicted value, and the n, this is the number of objects. What are the various characteristics of mean absolute error? It is easy to understand. It treats all errors equally, means no square terms will be there, and it is sensitive to outliers but not as much as mean square error. Okay. Then what is mean square error? I'll tell you about that. Just listen how actually this works. Mean square error means this is the average of the square differences between the actual and the predicted. Okay, means it penalizes larger errors more than the smaller ones, and it helps in optimizing the models, that is differentiable function. It is not interpretable in original units due to its square. Okay, then what is root mean squared error? Here, I'll explain this example. Root mean squared error is the square root of mean squared error, that converting the error back to the original units. Okay, this is the square root. Just here mean squared error. This is the square root of mean square. Just consider. Here, root mean square error, that is interpretable in the same units as the target variable. And here more sensitive, it is more sensitive to large errors compared to mean absolute error, but it can be influenced by the outliers. Okay, then how to implement? Suppose there are three observations, 1, 2, 3. The actual value is 3, 5, 7, and the predicted values are 2, 5, and 8. Okay, then the error can be calculated as, how the error can be calculated, anyone?
Predicted minus actual.
So here the mean square error can be calculated as the actual minus predicted value. Okay, sorry, the error, actual minus predicted value. Then the square error is the square of this. Then square error, getting it? Error and square error, everyone. Actual minus predicted is the error, then square error is the square of this. Getting it this much. If you can getting
sir.
it this much, then I'll explain further. Yeah. So mean square error is 1 upon n summation of y minus y dash square. Okay. Means actual minus predicted square. Means here actual minus predicted, here 1 plus 0 plus minus 1 upon n, means n is 3, then it comes around. This is the square of this. This is the square error you have found. Then 1 plus 1 plus 1 upon total number of observation is 3. It comes around 0.6. This is the average square difference between the actual and predicted error. How to calculate it? Getting it. This is a sample example. Getting it. How to calculate mean square error? Getting it or not? Any confusion? Do you have guys getting it or not? Still.
Yes,
So
sir.
please explain it once.
So there are 3 observations. That is 1, 2, 3. The actual values are 3, 5, 7, and the predicted values are 2, 5, and 3. How to calculate the error? It's actual minus predicted. 3 minus 2 is 1. 5 minus 5 is 0. 7 minus 8 is minus 1. This is y minus y dash. Here y is actual and y dash is the predicted. Then the square error means y minus y dash square. It means 1. Here, square of this 1. 0 square is 0. Minus 1 square 1. Getting it? This much.
Yes, sir.
Yes, sir.
Then how to calculate the mean squared error? I told you it is 1 upon n summation of y minus y dash square. So 1 upon n. N is the total number of observations. Means 1, 2, 3. 3 observations. Then square error. Summation of square error. It is 1 plus 0 plus 1 upon total number of observations. It is 2 by 3. That comes around 0.66. Getting it now?
Yes, sir.
Means the average of the square difference between the actual and the predicted. Then, what is mean absolute error? Mean absolute error formula is the magnitude of actual and predicted. So, magnitude 1 upon n is 3. Then the magnitude of this is 1 plus 0 plus minus 1. Magnitude means 1 plus 0 minus 1. Then the magnitude will remove. When will remove the magnitude. Means 1 plus 0 plus 1 upon 3 is equal to 2 by 3. Is equal to 0.6. Means the mean absolute error means what? It's the average absolute difference between the actual and predicted value. Okay. Means overally mean square error to calculate the square difference between the magnitude. Then root mean squared is the square root of mean squared error. The square root of 0.6 is root mean squared error. Then one thing counts. That is R2 score. This is important. R2 score means it measures how well the regression model explains the variance in the target value. The formula is R2 score is equal to 1 minus SS residual upon SS total. Okay. Means R square means it measures how well the regression model explains the variance in the target variable. Okay, it's means here SS residual means R square error is equal to the formula is 1 minus SS residual upon SS total. Here SS residual means the sum of square residual means the summation of this one. Then SS total means the sum of the total sum of the square. Means y minus y dash whole square. Okay. What are the characteristics of R2 score? Means the values range from 0 to 1. Okay. This comes under higher means when the values in R2 score ranges from 0 to 1. That is better. R2 score close to 1, that indicates it is excellent model. Excellent fit. If R2 score is less than 0, the model performance the worst. Okay, how to implement it? I think you can see my screen. Can you see my screen?
Yes, sir. Please maximize the screen.
Yes, sir.
First, importing the required libraries means to then from scalar dot matrices. It means maximum thing can be exported from a scale scikit-learn. Then import mean squared error, mean absolute error, active score, and ROC core and ABC value. And the actual value and the predicted value are given. Then RMS is the input square root. Actual one is predicted. And the mean absolute error is the minimum absolute error that is actual and predicted. Then, yeah, active score, actual and predicted. So here you can get it. Print RMSC, print MAE, and print R2 score. Here means RMS is 0.65, MA is not that good, 0.55. But R2 score is 0.9. Means it's quite good. Okay. Uh, Getting it, all of you.
Yes, sir.
Yes, sir.
How to
We are getting
calculate it.
Yes, sir.
exactly.
Okay.
So,
Let me download this so that you can get it. Okay. I'll share this. Don't worry. So
So,
the next, yes, sir.
so in this for the MAE, which is the main absolute error,
Yes.
so here is for the average absolute difference between the actual and the predicted values, right?
Hmm.
So here are the values are 1, 0, and -1.
Hmm.
So can you go back to the notepad, please?
Yes, definitely.
Okay. So here are there. Please correct me if I'm wrong. So 1 plus 0 minus 1 divided by 3. If that will be that for the
It's mean
MAE.
absolute. Yeah. Listen. When the magnitude will remove, that minus will become plus, right?
Okay. Because of the mod.
Yes.
Okay. 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 Thank you, sir.
I hope all of you getting it. Means
Yes, sir.
mean R2 score is a, when we're talking about what R2 score, when the value ranges from 0 to 1, means higher is better, and R2 is close to 1 is better. Okay? And if the R2 score is less than 0, the model performs worse. Worse. Okay. And how to implement it? What is standard deviation? It measures the spread of data points around the mean. I've discussed in the last class, and I've told you already how to calculate the standard deviation as well. Right, all of you?
Yes, sir.
Yes, sir.
So overall, ROC code, this is evaluation matrices is completed. Okay. Then EDA to be discussed. Okay. Tomorrow. Tomorrow we'll be having another class. I'll try to schedule 1 hour session. If 9 to 10, I'll schedule the class for you. Is that fine for everyone? Can you manage 9 to 10?
okay,
Yes,
sir,
sir.
it will fine.
Yes, sir.
Just help me with that. Okay. 9 to 10, is that okay? Or this this timing is
Yes, sir.
uh,
Okay for me.
Sir, 9 still okay.
Would work,
Yes,
sir.
sir. Okay, fine.
8 to 9? I'm asking about 9 to 10.
No, sir. 8 to 9 would be fine, sir.
Okay. I'll try.
8 to 9 is good, sir.